There, science teachers, I'm going to tell you how to use your computer and the camera on it to get some excellent data for the car running down the slope experiment. I've just been talking to Jackie and we've discovered that although her results using her slow motion video, here's my slow motion of the car sliding down the hill, are pretty awesome, there are two issues. Firstly, we don't know how long it took to go down the hill, and second, because the ramp is sloped relative, or at an angle relative to the camera on the computer, it makes both a horizontal and a vertical component to the motion, and we don't want that. So what I've done used my photo booth to take a video, and I tilted my laptop so that the ruler, which is sitting on top of my ramp, is almost parallel with the line along the bottom of my photo booth, so I know that their motion will just be considered as horizontal. So I've taken a video. My video looks like this. So it starts at the top, goes, whee, the car runs down, that's it. So that's all I'm really interested in, 2 or 3 seconds of video. On my ruler, if you look closely, and I'll let you do that by me zooming in, you can see I've marked at 10 centimeters, and I've also marked at 50 centimeters on the ruler so I can see it more clearly. You can't read the numbers very clearly on the ruler using the cameras on our computers if it's a bit dark, like I was being under the cupboard. So we've got the ruler, and I've put some marks on it so it's easier to read. What we need to do is import that into Logger Pro. So I'm going to open up Logger Pro, and when Logger Pro opens up, we're going to go to Insert, Movie, and then we're going to choose that movie. It's not an experiment, mine's on my desktop, just sitting there waiting to be used. So there's my movie, and when I click on it and double click or click on open, then I get my video. And you can see it's the same video, there it goes. You can't hear Mrs. Raj's laughter, but I'm sure it would have been there. So it's very nice and whizzes along. I'm going to move my car forward a little bit by moving the time slider along, and then down in the bottom right hand corner down here there are 3 little dots followed by an arrow, and that's the video analysis tools. So I'll click on it once and up come these tools. The first tool I want to use is the set scale. It's the one that looks like a yellow and black stripy ruler. So there it is. I've clicked on it. I'm going to start off at 0 distance, as I'm going to count it as, and I'm going to go up to 40 centimeters. In reality, I've clicked on 10 centimeters and 50, but the distance between them is 40 centimeters. When I release my mouse button, it asks me how far apart those things were. So I know 0.4 meters. Now, if your students haven't done that, well, they should have, but they could choose something else. They could take the length of the car, and they could measure the length of the car beforehand or afterwards, and then set the scale according to the length of the car. But it's a much better idea to have a longer distance because we might get a slightly more reliable set of data. Next, they're going to add some points. Now, points plot 2 things. They plot the horizontal and vertical position of where you click them. And they'll also link that up with the time of the video. So I'm going to move my video forwards using the time slider along the bottom until the car's just about to move. And I'm going to click on my Add Point button, the cross with a red dot. And I'm just going to click on the front of the car. Click on the front of the car. Each time I click on the front of the car, the time slider moves forward a fraction, and so does my car as a result. So I'm going to keep on clicking and click and click, as long as I'm always clicking on the same part of the car, and I've chosen the front right hand corner of the bonnet of the car just as an easy place to recognize. As the car goes faster, it becomes harder and harder to see. It becomes more and more blurred. And if you've got a bit of paper stuck on the back of your car like mine has, then you can't see the front corner. Maybe I should have chosen the other corner. But there's my last point. I've got my points on. They don't look very exciting there, but you can see just behind my image something's starting to happen. So I'm going to click on my video screen and press the delete key, and it vanishes. And there behind it is this beautiful red dotted curved shape. There's also got a blue one. The blue is the vertical movement. So I mentioned before we wanted to have the video horizontal so that we don't have any vertical, and mine's just gone a little bit, that's fine. We've got a nice shape, that's showing that we start off with very little velocity and end up with lots of velocity. What has happened with mine is because I've gone from right to left instead of left to right, it starts off at 50 centimeters and goes down to 10 centimeters instead of going from 0 to 50. But you can flip over your video, or students can flip over the video if you want to do that. Now, if I shrink my graph a little bit, I can stretch out the actual results so you can see what they're like. And there's a scroller along the bottom so I can see all of them. My first column is the time, as worked out by the position on the video clip. So mine goes from 0.2 seconds up to 1.1 second. And it has my X position and it's got my Y position. I'm not interested in the Y position, so this whole column is unneeded. The wonderful thing about this, as well as the position, the manufacturers have realized that it's quite a good idea to have the velocity. So if I look at the X velocity, I started off going backwards apparently, and then I accelerated until my velocity was 0.8 meters per second. But it says it's negative because I'm going backwards. Students can, if they want to, export their data. They can export it as text or as a CSV file. It's nice and easy to use. Give it a name, say test of ramp data, and I'm going to put mine on the desktop. When you go to the desktop and you find your test of ramp data, mine opens up in Excel. They can open up their data in Numbers if they wish, or in Google Spreadsheets. They can choose columns A and B, and then they can put those results into a graph. So I'd go Insert, Chart, and up comes my option for Scatter Graph, Mark Scatter, and there's my data. Looks the same. The only advantage now is I can right click and add a trend line. And because I've had a trend line and I know that I'm going to go for a second order polynomial, first order polynomial, first order doesn't exist. I'm going to add my polynomial graph, and when I click on it, I also get the option to format my trend line and add in options the equation for the graph. There's my equation. You can just read it down the bottom there. Click on OK. So that shows how we can get some nice results using the camera. You can then choose to change the angle of the slope or the frictional surface that you're using. Perhaps you can have bigger or smaller masses on the car. That shouldn't change how fast they go. Things that will change how fast the car goes are definitely the slope. As you increase the slope, we should find we get a non-linear change in acceleration. I'm sure you can work out the acceleration curve. If you're unsure, I'll tell you how later. Okay, I hope this helps. Bye-bye.